Hey everybody, this is Mrs. Snook with section 7.2, Systems of Linear Equations in Two Variables. Now this should be a review of what you have done in Algebra 1. You did systems of equations. Our objectives are to use the method of elimination to solve systems of linear equations in two variables, to graphically interpret the number of solutions of a system of linear equations in two variables, and to use systems of linear equations in two variables to model and solve real-life problems. So last section 7.1, we did graphical method and we did substitution. This is the third method for solving linear equations in two variables, and that's elimination. And what that means is you literally eliminate one of the variables. And then when you do that, you end up with an equation with only one variable that you can then solve. So take a look at our first example. Our first equation is 3x plus 2y equals 4. And our second is 5x minus 2y equals 8. So I'm going to look at the y's. I have a plus 2y and a minus 2y. So if I add these two equations together, those y's are going to drop out. So let's go ahead and do that. So 3x plus 5x is 8x. I have a 2y minus a 2y, that drops out. And then 4 plus 8 is 12. So now I have a very simple equation, 8x equals 12. And when I solve that, I'm going to get x equals 12 over 8, and that reduces to 3 over 2. Now go back, pick one of the equations, and plug in your x and solve for y. So 3 times 3 over 2, I'm just using our first equation, plus 2y equals 4. So I just grabbed that equation and now I've just plugged in my 3 over 2. So I get 9 halves plus 2y equals 4. Now when I solve this, I'm going to subtract 9 halves from both sides. I'm going to rewrite the 4 as 8 over 2. So when I subtract my 9 halves, I have a common denominator. I'm going to get 2y equals negative 1 half, and then divide that by 2, I get y equals negative 1/4. So my final answer for this system is x is 3 halves and y is negative 1/4. All right, let's do another one. Now this time when I look at my system, I don't see a variable that just drops out easily by adding the equations together. So what I'm going to have to do is multiply. And I'm going to multiply each equation by a different number and then force one of my variables to drop out. And here's how I'm going to do that. I have this coefficient 5 in front of x in my first equation. So I'm going to multiply the second equation by 5. And I'm going to make that a negative 5 so that my signs are opposite. Now for my first equation, I'm going to take the 2, that's the coefficient of x in the second equation, and I'm going to multiply the first equation by that 2. And so watch what happens. I just distribute my 2, so I get 10x plus 6y equals, and distribute the 2 across here, 18. And now I'm going to distribute the negative 5 in both equations. Sorry, both sides of the equation. So I get negative 10x plus 20y equals negative 70. Now when I add these equations together, those 10x's drop out. So that's why I chose the coefficients as I did, so that I could force my x to drop out. That leaves me with 26y equals 52. That's a negative 52. And then y equals negative 2. Now all I have to do is go back, plug that y in, and I can get x. So last time I used the first equation. Let's use the second equation. It doesn't matter. So I just want to show you that it works either way. So I'm going to use 2x minus 4y equals 14. I'm going to plug in that y that I got. So 2x minus 4 times the negative 2 equals 14. So 2x plus 8 equals 14. Now subtract that 8 from both sides. 2x equals 6, so x equals 3. So my final answer for this one is 3, negative 2. Okay, so now let's go on to our next idea, and that is by using graphs, we can determine the number of solutions to each of these linear systems. I'm not actually going to solve them. I just want to know how many solutions I have. So what I'm going to do is I'm going to graph these in Desmos. So let's pull up Desmos. And our first one is 2x minus 3y equals 3, so that's in red. And then my other equation is negative 4x plus 6y equals 6. So where's my negative? I'm going to do like this. Negative 4x plus 6y equals 6. And take a look over here. You see how the red line and the green line are parallel to each other? They never intersect, so that's a no solution case. So in my notes, I'm going to draw a picture of what this looked like. I had two lines. One was like this and one was like that. And because that's what it looked like, I have no solution. All right, let's look at the next one. I have the same 2x minus 3y equals 3, but this time I have x plus 2y equals 5. So let's put that one in. X plus 2y equals 5. And now I have an intersection point. So that is one solution. And if I wanted to, I could find out what that solution is. Let's see what it is. I'm going to come over here. It's the point 31, so x is 3, y equals 1 is our one solution. So over here in my notes, I want to draw a picture of what that looked like. And I had one going like this, and the other was going like that. So I had one solution. Let's do our last one. This time we have negative 4x plus 6y equals negative 6. And check it out. So I'm going to turn off the red line, so all you see is the green line. Now let's turn on the red and turn off the green. Let's turn them both on. So what we see here is that the two lines are landing right on top of each other. So that means we have infinitely many solutions. Every single point on either of those two lines counts as a solution. So when I draw my picture of that, I have one graph like this, and then the other one was right on top of it. All right, the next one we're going to do is we're going to do method of elimination for the no solution case. So these two equations, if I was to graph them, they should look like two parallel lines like we had in example A. So let's see what happens when I do it by elimination. So I'm looking at my x, and my coefficient in front of x in equation number 1 is an invisible 1. And then in equation number 2, I have a negative 2. So what I'm going to do is I'm going to multiply my first equation by a positive 2. And let's see what happens. So I get 2x minus 4y equals 6. And then my second equation just stays as it is, negative 2x plus 4y equals 1. Now add them together. I have 2x minus 2x, so the x's go away. Negative 4y plus 4y, so the y's go away. That leaves me nothing left on my left side, so that's a 0. Equals, now let's add the right side. 6 plus 1 is 7. 0 does not equal 7. Never, ever, ever equals 7. Therefore, because this never works, this is no solution. And what tips you off for that is you get an answer at the end that can never work. 0 is never 7. Not ever. Now let's look at another one. This time it's the method of elimination, but the infinitely many cases. So if I were to graph these two, what I should get is like an example C here, where the two lines lay down on top of each other. But we're not going to actually graph them. Let's solve them with elimination. I'm looking at my x coefficients, and I see I have a 2 and a 4. So I'm going to multiply my first equation by a negative 2. And when I do that, I get negative 4x plus 2y equals negative 2. And then my second equation I'm going to leave as it is, so 4x minus 2y equals 2. Now let's add them together. 4x minus 4x, gone. 2y minus 2y, gone. So that leaves 0 on the left side. Negative 2 plus 2, gone. I get a 0 on the right side. That is always true. 0 always equals 0, so this is infinitely many. So if you get an always true, 0 equals 0, 5 equals 5, as long as both sides are the same, that's always going to be true. You have an infinitely many case. All right, our last example is the real world example, and it comes from the world of aviation. We have an airplane flying into a headwind, travels the 2,000-mile flying distance between Cleveland, Ohio and Fresno, California in 4 hours, 24 minutes. On the return flight, the same distance is traveled in 4 hours. Find the airspeed of the plane and the speed of the wind, assuming both are constant. So the first thing I'm going to do is I'm defining some variables. A is going to be the airspeed of plane. W is going to be speed of the wind. So wind speed. Now I've got two situations, and I'm going to write an equation for each one. My first situation is flying from Cleveland to Fresno. So the Cleveland to Fresno run. Now in that situation, the time was 4 hours, 24 minutes. So 4 hours plus 24 minutes. Now, because I have hours and minutes, I need to multiply by a conversion factor. And I'm going to go ahead and stay in hours. So my factor is going to be hours over minutes. And I know that there is 60 minutes in 1 hour, so I'm multiplying by 1 over 60. And when I do that, the time that I get is 4 hours plus 0.4 hours. So my total time is 4.4 hours. Now let's write my equation. Now I'm traveling a distance of 2,000 miles. So I'm going to put 2,000 over here. My airspeed times its time is going to be one distance. And then if I do wind speed times its time, I get another distance. And those two distances added together have to be 2,000. So 4.4, that's the time, times my airspeed. And I have a 4.4 times my wind speed. But this is a headwind, so it's working against the plane. So I'm going to put a minus in there. That's my first equation. Now my other scenario is going back the other way. So this is going to be Fresno to Cleveland. And I'm told here the time is 4 hours. So my equation is going to be 4 hours of the airspeed, and then we have 4 hours of the wind speed. This also equals 2,000. But since it's going the other way, this isn't a headwind anymore. It's a tailwind. It is helping the plane. So I put a plus in there. And that's my second equation. So now I've got my two equations. I'm going to go ahead and solve these. And when I look at my coefficients, I notice that if I multiply my Fresno to Cleveland equation, if I multiply that by 1.1, I can get my wind speeds to cancel out. Because look at what happens when I do the 1.1. I get 4.4a plus 4.4w equals 2,200. I'm going to have a negative 4.4w and a positive 4.4w. So when I add those two equations together, my w is going to drop out. So let's go ahead and do that. So first equation, 4.4a minus 4.4w equals 2,000. Second equation, 4.4a plus 4.4w equals 2,200. Add them together. W is gone, and I get 8.8a equals 4,200. So now just divide both sides by 8.a, and a is going to be 477.27 miles per hour. Okay, I've got A. Let's get W. And I think it's easiest to plug A into my original equation too, the one with just the 4s and not with those decimals. So I'm going to say 4A plus 4W equals 2,000. I'm going to plug in my 477.27 for A. So 4 times 477.27 plus 4W equals 2,000. Okay, I'm going to multiply my 477.27 by 4. And I get 1909.09, and that's repeating, plus 4W equals 2,000. Now I'm subtracting that, and then dividing by 4, and so W equals 90.90. That's 4W. So what I did is I subtracted the 1909 from both sides. Now I'm going to divide by 4, and W equals 27.72 miles per hour. So those are the answers to our equation. The airspeed of the plane is 477.27 miles per hour, and that wind is 27.72 miles per hour. And the interesting thing is, compared to the speed of the plane, the wind isn't much at all, but yet it makes a 24-minute difference in the travel time. And that's something passengers would notice. All right, so that's it for today. Thank you for watching, everybody, and have a great day.